All right, this is part 2 of our section 3.4, and we just got done talking about z-scores and what those meant, how we were able to compare two data values that came from different data sets, convert them into a z-score, and now, then convert them into a z-score and then compare those z-scores. Now we're going to interpret this concept called a percentile. You've probably heard of this, but we're going to go into a little bit more depth. So recall that the median divides the lower 50% of the set of data from the upper 50%. It's right down the middle, 50% above, 50% below. Okay, the median is a special case of this general concept that we call a percentile. So the kth percentile, and that will be denoted by P sub k, so like the 20th percentile will be P sub 20. So the kth percentile of a data set is a value such that k% of the observations are less than or equal to that value. Okay, so percentiles divide a set of data that is written in ascending order into 100 different parts. Okay, and so thus we can get 99 percentiles that can be determined. So for example, P1 down here, P sub 1 divides the bottom 1% of the observations from the top 99%. P sub 2 divides the bottom 2% of the observations from the top 99 or 98%, and so on. Okay. And so when we talk about percentiles, they're used to give the relative standing of an observation, where it stands amongst all the others. So many standardized exams, such as an SAT score, use percentiles to let students know how they scored in relation to others who took the exam. And so, like if you were, say you were the 20th percentile, that means that that 20% of, so if you're taking the ACT score and you got a 20th percentile, that means 20% of the people scored the same or lower than you did. If you got the 85th percentile, that means that 85% scored the same or lower than you. So it tells you, kind of in percentile terms, it tells you how high or low you lie in terms of, if you were to line up all the data, where you would be at. Okay, so let's try and explain some of these meanings here. So we've got, let's see, so we've got the 5th percentile of the weight of males 36 months of age is 12 kilograms. So how would we explain that? So if you're the 5th percentile, that means 5% of 36-month-old males weigh less than or equal to 12 kilograms. Okay, and then you could also say that 95% weigh more than 12 kilograms. Okay, so that's another way to interpret the percentile. So then for the 95th percentile of the length of newborn females is 53.8 centimeters, then we would say that 95% of newborn females have a length of 53.8 centimeters or less than. Okay. You can also say that 5% of newborn females have a length of 53.8 centimeters or greater than that. So greater than or equal to 53.8 centimeters. Okay, so again, that's just the idea of the percentile. It tells you if you're the 57th percentile, then 57% are either equal to or less than that number. Okay, now there's some pretty popular percentiles that we use, and we give them names, and the names are very straightforward, and those are the quartiles. Okay, the quartiles divide the data set into fourths, or 4 equal parts. So the first quartile, which will be denoted Q1, divides the bottom 25% from the top 75%. Okay, and that's equal to the 25th percentile by definition. The second quartile, Q2, divides the bottom 50 from the top 50. It's the 50th percentile. It's also the median. Okay, the third quartile, Q3, divides the bottom 75% from the top 25% and is known as the 75th percentile. So these are things that we're going to be using quite a bit, and you can see a little picture down here where Q1, Q2, and Q3 land, and then the smallest data point, which is the minimum. You have the largest data point. That's actually what we're going to call later the 5-number summary, which will help us create a box plot. But again, it breaks down. There are 4 different areas here, and those quartiles help cut it into the fourths. So finding quartiles, just like finding the median. Okay, you arrange the data in ascending order. The easiest way is to first identify the median, which is the second quartile, and then you divide the set into halves. So the observations that are below or to the left of the median, and then the observations that are above or to the right. The first quartile is the median of the bottom half, and the third quartile, Q3, is the median of the top half. Okay, and we're not going to spend a lot of time doing it by hand, but just so you can get an idea, that's what it means. Because StatCruncher is going to help us get those. Now, we've discussed measured dispersion, range, standard deviations, variance, all of these, which are, those aren't very resistant. But quartiles, just like because a median is in that category, quartiles are very resistant. Okay, so for this reason, quartiles are used to define a 4th measure of dispersion, which is called the interquartile range. And that's the middle 50% of the observations in a data set. And interquartile range is shortened by, or used as IQR for short. Okay, the IQR is the difference between the third and first quartile. So Q3 minus Q1 is what we call the interquartile range. And that gives us the middle 50% of our data and our observations. Okay, so the interpretation of the interquartile range is similar to that of the range and standard deviation. Okay, so that is, the more spread a set of data has, the higher the interquartile range will be. So more spread is going to lead to a higher interquartile range, which hopefully makes sense, because if you spread it out more, your quartiles are going to spread a little bit more, and that difference between Q3 and Q1 will spread. Okay. Now the last thing we're going to talk about, and then we'll get into some actual questions, is we're going to check for outliers. Okay, now when you're performing any type of data analysis, you should always check for extreme observations. We refer to those extreme observations as outliers. They can occur by chance because of an error measurement of the variable during data entry or from errors in sampling. Okay, but the way we do this is first you identify the first and the third quartiles, then you compute your interquartile range, and then we determine what are called the fences. And the fences are just the cutoff points for determining outliers. So the lower fence is you take Q1 minus 1.5 times an IQR, and anything lower than that is an outlier. Then we have our upper fence, which is Q3 plus 1.5 times the IQR, and that will give us our upper fence. Anything that's below the lower fence or above the upper fence is an outlier, or it's an extreme observation. And you might want to take a closer look at it, see if there was an error in the measurement or if something went wrong in gathering the data. Okay. So now we're going to take a look at a couple of problems here. So the first one is dealing with a smart car. And so we've got the following data represent the miles per gallon of a random sample of smart cars with 3-cylinder 1.0 liter engines. So all of these right here are miles per gallon. And we want to compute a z-score corresponding to the individual who obtained 36.3 miles per gallon and interpret our results. So in order to do this, we're going to need the sample mean, and then that'll help us determine a z-score. We're going to find the quartiles, the interquartile range, the upper and lower fences, identify any outliers. So we're going to need to go over to StatCrunch. So I'm going to pause the video and I'm going to jump into StatCrunch, pull in all this information, and we'll go through it there. Okay, so now we've got it data into StatCrunch here, and I'm going to go into Stat, Summary Stats by columns. Okay, I need to select the smart car, and again, we've done this before where we get the mean, the standard deviation, all those awesome things. If you scroll down, you'll see that Q1 and Q3 are also highlighted, and here's the IQR. So you're going to have to naturally highlight this one on your own. So on a Mac, I'm just going to hold the Command key and select the IQR. On a Windows computer, I believe it's the Control key. Okay, so that's going to give us our IQR. So I'm going to compute this, and you can see Q1 of the data set is 36.85, Q3 is 41, and the difference between those, so 41 minus 36.85 is 4.15, which is our IQR. So there's all of our data that we need. Oops, wrong question here. Oh, and also we're going to need our mean. Forgot we were finding that z-score first. So our mean is 38.775. So when I find a z-score of 36.3, so I take 36.3 minus that mean, 38.775, and divide it by our standard deviation. Okay, and our standard deviation is 3.42. And I'll just do 3.416. Okay, this will give us approximately, when I do this out in a calculator, it's going to be negative because we're below the mean, so it's negative 0.73. Okay, and again, that z-score just means we are 0.73 standard deviations below the mean. Okay. So next was determine the quartiles. So our quartiles, Q1 was 36.85. Q3 was 41. Okay. And then our IQR, again, it's just the difference, 41 minus 36.85, which is 4.15. So there's your IQR. Okay, now the lower fence is Q1, 36.85 minus 1.5 times the IQR. Okay, which is equal to 30.625. So there's our lower fence. The upper fence is going to be quartile 3 plus 1.5 times 4.15 because we want to go above the third quartile. And that's 47.225. Okay, and then we check to see in our data set, is there anything below 30.625 or is there anything above 47.225? And if so, those numbers are outliers. And if we look here, 47.5 is greater than our upper fence, so 47.5 is an outlier. Okay, and that's the only one that would be an outlier in this case. So we'll pick it up in a part 3.